Alright guys, so today we're going to continue our talk of negations, and we kind of touched on this already about the negation of an existential statement. So, example 5. So, let's just highlight this. Negation of an existential statement. Example 5. Write the negation of the following statement. Some functions are quadratic functions. Now, remember we talked about how if you had some or all, you don't just put not in there. So I kind of got ahead of myself with sharing that with you on the last video. But the negation would not be some functions are not quadratic functions, because then, and I don't know why there's a 3 there, because then both the statement and the negation would be true. Okay, so some functions are quadratic functions, some functions are not. So because some means it could be or not be, you can't have, remember, negation changes the truth value, which means it would become false. So remember, when you negate an existential statement, it becomes a universal statement. So the original statement is, there exists a function x such that x is a quadratic function. So remember, you would change it to a universal statement, so that would become, for all functions x, and you don't leave in such that because that only goes with the there exists. For all functions x, x is not a quadratic function. In the informal one, you would say, for all, you would put all functions are not quadratic functions. Okay, and that seems like a lot of words. All functions are not. So how would you make that flow better? So those of you that are better at English than you are at math, this is right up your alley. So what would make that sentence flow better? And it would be, no function is a quadratic function. But I would take either one of these. It would be fine. No function is a quadratic function. Okay, so the theorem, which is the negation of an existential, says the negation of there exists x in S such that P of x would become, for all x in S, x, or let's see, you would put not px. Okay, so it would be px and then not px. Okay, now complex statements complex statements are statements that contain both for all and there exist. So it's like a marriage between universal and existential. So you would see something like this. For all real numbers x, there exists a real number y. So it's when you usually have two values such that x, y equals 1. All right. So how would we write this statement? For all real numbers x, so for all real numbers x, there exists a real number, and you don't use your R there because this is one singular, this is the whole set. Real number y such that xy equals 1. So how would we change it? Okay, so we would put there exists a real number x such that for all real numbers y, you would put x, y, and remember that we put a not here. So you would put not equal to 1. So notice we changed this, we changed this, and we changed this when you negate it. Okay? So let's try one more. There exists a real number m such that mx squared is less than 0 for all real numbers x. All right, so here we go. There exists a real number m, real number m, such that for all real numbers x, mx squared less than or equal to 0. Okay. They didn't word that very well, but that's what it means. Okay, so here we go. So we'd say for all real numbers m, there exists a real number x such that, remember we changed the symbol here, mx squared is greater than 0. So we change 1, 2, 3. So how would we read this informally? And this is the last thing. For all real numbers m, mx squared is greater than 0 for some numbers x for some real numbers x. Okay, so that was just the last little bit of that lesson that I wanted to cover with you. And then you got an assignment. Let me know if you have any questions. Thanks, guys.